Good evening and welcome to this evening's webinar, Coding with TI-nspire Technology, hosted by Texas Instruments Australia. My name is Rodney Anderson and I will be your host for the webinar.
And telling you, just as you were hearing from John, from O'Loughlin Catholic College, which is in Jindabyne, is it not, John?
No, it's in Darwin, although I'm having a year's leave without pay.
We've got an old slide here.
I know,
So
I know.
Tell us the
down
story.
in the cold, obviously, going from Darwin to the Snowy Mountains for a year, but I'll be back in Darwin next year.
Okay, extremes of weather and temperature. So John, of course, brings us a wealth of experience on a couple of TI platforms. We ran a webinar last night talking about coding using the TI-84, which I also have a fair bit of experience with. And this evening we're looking at the same sort of deal, but with the Inspire. And here you have, well, it's scary, you get a picture of me. I'm going to swap across to my own PowerPoint now, and that same panel, so that I can overview what's happening in this evening's webinar, because that's what you want to know. I'm going to talk about a lovely support activity or set of activities called 10 Minutes of Code, which is available on the TI website. And then John will tell you a bit about how it really works in a classroom, sharing his classroom experience and some of the coding and programs that he's made, including some step-by-step simple programs, then programs that involve decision-making, for example, you know, the if-then statements and greater than, less than, and logical decisions, loops, and then subroutines, including putting a program within a program. If we get time, then we'll scoot back to me, and I'm just going to give you a sneak preview of something that's coming down the track called TI Innovator. I've only seen early models of this, but it's on its way. I think it's already released in the United States. It will be in Australia soon, and I'll tell you more about that at the end of the webinar if we get there. Okay, can I ask you to please, as we enter into the realms of coding, and it's certainly become a bit of a catchphrase, you'd have to be hiding under a rock to have missed it, I think. So instead of programming, we're now saying coding. I'm not sure I really know the difference between the two. But I do know that when I first used a computer, it was in fact for coding/programming. I was at college at the time, and the massive computer lived in a room somewhere else in the building. I had a VDU terminal and keyboard, and I was very fortunate because if I had started 1 year earlier, I would have been having to deal with punch cards. Fortran was the language we were working with, and I could type some code and compile and execute it straight away, which was really good, and then correct it. So what's your story? Did you use a computer before you did coding, or was it both at the same time? Have you ever taught it? Did you teach computers or computing studies? I know it's something that was often dumped upon maths teachers, and I don't know that that's really the best realm for computer studies. I think it's now seen as something right across the curriculum, as also is coding. What languages and applications did you use? Are you teaching it now, or have you done so recently? And most importantly, what resources have you come across? What are you using? What would you recommend? Because I can tell you something I'm going to recommend. Leading on from the big fuss about coding, and you see here I've quoted the Federal Minister for Education from last year, Christopher Pyne, talking about the importance of coding across the curriculum, and he backed the idea up with even a bit of a promise of money, and the support of high-quality teaching in technologies. Additional to that, I found a study that was carried out by Adelaide University on coding across the curriculum. There's the press statement from Mr. Pyne. And from Adelaide University, the recommendations about resources, the study was focused on resources, but the idea of supplementary materials being developed, algorithm design, programming, and I particularly like this one, resources associated with general purpose programming languages developed to support teachers with beginner competency. See those terms, beginner competency. The 10 minutes of code that I'm about to show you, you can walk into that, or your students can walk into that with absolutely no programming or coding experience. It takes you by the hand, step by step, and I'm not sure why it's called 10 minutes of coding. There's actually hours of material there, but I think maybe the idea is that within 10 minutes, your students will only need an investment of 10 minutes, and they will be producing meaningful code. And this is a copy of the homepage of the Australian Texas Instruments website. You've already found the link on webinars, obviously, because that's where you are now. And this link here takes you into the 10 minutes of code. When you're there, it's Choose Your Weapon, the TI-84 Plus series, or TI-nspire. For this evening, we look at TI-nspire. There are two parts within there. A student part here, 10 minutes of code, and the teacher's lounge. I like the idea of the lounge, that's good. But with the students, the coding lessons are comprised in 5 units. Each unit has 3 skill builders, step by step, and 1 application. So the application is an opportunity, it's a challenge for students to then put into practice what they've learnt through the 3 skill builders and the ideas that were introduced through them. This I'm about to show you will happen step by step on the screen. You can use that on computers in your class with students. However, if your students don't have class time access to computers, or another way of doing it, through the Teachers Lounge you can actually download PDF copies of the entire set of lessons. There's also additional files there for the teacher rather than just the student, and also there's links to further e-books that contain greater detail. I'll just show you that PDF. I downloaded it earlier. 10 minutes of code, and in here you see the 5 units, and Unit 1, Skill Builder 1 for the student, looks a little like this. You're about to see the same thing on the website, but here's a 2-page PDF that you could photocopy. Look, it's so step-by-step procedural, and students love getting into this. They love algorithmic things. This is the sort of thing you could even leave for an extra.
That's right. And Brian, it takes the pressure off the teacher, doesn't it? Like, whether you're experienced with coding or not, or whether you're experienced with the TI-nspire or not, it really takes the pressure off the teacher and puts the onus on the students. And therefore, the teacher can be a facilitator rather than actually have to be the expert.
Indeed, indeed. And I've found, look, I must confess, John, you've written some great codes and programs for preparation for these webinars, and also with your students. I've never been a big fan of coding. I've found it a little bit, I guess, shall we say, tedious. But students love it, though. They get into it, and they're producing something fairly quickly. Here's the teacher notes. Even within the teacher notes, you don't necessarily get the full programs written. That one does, just here. But the idea is that students are working step by step and problem solving and encountering problems and correcting as they go. So let's jump back into that PowerPoint. 10 minutes of code. Let's have a look at what it looks like on the web. I've linked it from here, and here we go. I'll just maximize this. So front page of the TI website, 10 minutes of code, as I showed you before. Choose your weapon. TI-nspire is good, and we'll go to start here. It's as simple as that. These are the 5 units and what happens in each. Very basics in the first. The use of variables introduced in the second. Conditional statements in the third. Loops, and then look, we're getting into graphs and some dynamic programs. Even if you don't have the software, I thought there's lovely link here. If you don't have the emulator software, which I'm about to show you, I've got it sitting right here. There it is. Even if you don't have that, you can download a free trial here for 90 days. So that's pretty handy. So let's see what this looks like. Unit 1, Program Basics. We're given the objectives for the unit. And as I explained before, 3 skill builders plus an application. Step 1. Okay. Turn on my calculator, open a calculator page. I just happen to have my calculator sitting here, and what I'm going to do is set it up so that side by side you're going to see the instructions from the web and my calculator. Isn't that a clever idea? So it says switch it on, turn on a calculator page, which I've already done, hit the menu key, go to the 9th option in the menu.
I'm not seeing your calculator by the side at the moment.
Okay.
I don't know whether there's a cross-country internet problem, but I'm only actually seeing the.
Is it a width of screen thing? Do you see it if I move it into the middle?
I'm not even seeing you on the first skill builder, so I don't know whether perhaps if some of the participants or the attendees could actually make a comment in the chat window and see whether they can see it. That would be good. But I'm only seeing your.
I'm seeing your screen at the correct side.
Okay, so maybe it's mine then. So let's just roll with you then for now. If everyone else can see it, that's fine with me. I'll keep quiet.
A gin-divine thing.
No, this person here said they Hong Tai says they can't see the calculator.
Oh, okay. So you may not have those problems in Darwin, you know. What I'll do is I need both. I'll move that across. Is it a screen width thing? Because there's the calculator.
No, I think it's frozen. I think it's frozen.
It's frozen.
Yep.
What I'm going to do, I'm going to hand the ball back to you, and I'll stop sharing and I'll reshare. See if we can reboot the show from there. So thank you for your patience.
How you going, Brian?
Yep, we'll give it a go. So setting up the sharing here.
I was looking forward to learning a bit about coding.
Yeah, well, look, I've done a bit, and it's been good fun, really. And I tell you what, these little calculators, they're more reliable apparently than the WebEx thing at the moment. Well, I'm back in sharing at the moment, and I can tell you what I'm seeing on my screen, a thing that says I'm sharing, and because I am sharing with the guy.
There we go. I think we're looking good.
Calculator on the right-hand side, and the skill builder's instructions on the left. So let's continue. And so it was asking me to set up a functions and programs from the menu and go to the program editor and select new. So basically that's just organized a window to allow me to start a new program. What do I do next? I go back over here and I'll click on step 2, and it says call my new program hello. Okay, that's a good idea. And I'm going to do this very quickly because I can use the keyboard. So hello, and file type is program. Next down it says library access. I'm leaving that as none. Through subsequent lessons, it teaches you a little bit about library access and what that means. Basically, it's the accessibility of your program from within this document or available from other documents. You could write something that can be then called upon from a new document that you might create at a later stage. Now I'm just going to maximize this again, because I just want to show you, I'm aware that this will be very small on that screen, but here you see the calculator keypad and the side screen. When we commence a program, we've got what's called split screen. On the right, I've got the program code, and on the left, if I click in the left, or you would use control left and control right, if I click in the left, I've got the normal calculator screen, and I can do things like that, or I could run programs. I can't run hello yet because it's not yet doing anything. Now, it's handy to type the code and then be able to compile it and run it all in one screen. Alternatively, if you want more space, which I'm going to go with because of the small screen I've already got, if you want more space, go to the document key and select page layout and see the 8th command is ungroup. So I've ungrouped those pages now. And you see the calculator page is now 1.1. If I take a look at 1.2, there's the program page. If I want to regroup at any stage, if I go back to 1.1 and then select Document, Page Layout, and Group, what group will do is it groups my current page, that is page 1.1, with the following page, page 1.2 as it was.
Nice little tip that, Brian. Thank you very much.
Yeah. And of course it can be used in many things. You could have statistics, a statistics plot, for example, on one page and the spreadsheet on the other.
It's also useful if you want to actually hide the program, the workings of the program, and just show the actual program in action and see if the students can actually work out what the how the program's written and what's behind the program.
Yes, yeah, that is a good point. So they can they're not to hide the coding and then gradually reveal it. So let's continue working through this. So I'm hoping now you see the 10 minutes of coding on the left and my calculator on the right. So I'm going to go to step 3, and the two computer screens look pretty similar, except of course I have unsplit my calculator screen. And it's now saying that if I go back to the menu key, I'm getting a different set of menus because it's now in a different mode. It's in this program mode, and it's suggesting I select number 6, which is I/O. You're probably guessing it stands for input-output, and if you did, you're correct. And the first option there is DISP, and if you're thinking that stands for display, again, you are correct, but I put it in the wrong spot, did I not? I need to put that in the little box here with the dotted frame around it. So I'll just repeat those steps. So the program name, define hello, and you see it's open brackets, close brackets, program and end program. In the box I'm putting the code. So I/O display. And what are we going to display? I'll jump back into my instructions and go to step 5, and it tells me to put in inverted commas, hello world. So I'll try that. So in inverted, back in my calculator I will. The benefit of working from a keyboard. And that's now done. See what happens next. Step 6. Okay, I now have to check the syntax and store. Let's give that a go.
And that section there, Brian, is easy for people to forget. The actual check syntax and store after every time you've done the program you want to run it. That's exactly where you need to go. The nice thing about that as well, not only does it give you the thumbs up, which is as you're going to show in a second, but it also, if it has a fault, it will take you to that fault, which is very helpful.
Yeah, so it's not just storing, it is checking.
Yeah.
And you'll notice there's a shortcut as well. So if you're doing a bit of this, you'll regularly start to do Control B. So you can probably guess what happens next. It says go to the calculator page and execute our program. Let's give that a shot. So I'm on my calculator page, and I could actually type in hello bracket bracket, but what I find is handy is it's also come up as a variable. Because it's now stored, it's a variable in this document. So I find a faster way of doing things is hit the var key and just run it, hello, and hit enter. So it's got the two brackets, hit enter. Hello world, it's worked. And so if I click back on the next step, it says, by Jove, you are clever. Thank you. Congratulates me, and I'm feeling pumped, I'm feeling good, and I'm ready for Skill Builder 2. Assign values to the variables. Let's have a go. Step 1. Oh, hypotenuse, this is sounding scary now. I'm going to start a new problem here. So I will go Document and insert a new problem, just so that variables and things don't step across each other. So problem 2.1. I'm going to define the program Hypotenuse. The difference now is that it's got, in those brackets, it's got an A-B type thing. So new program, Hypotenuse. And I'll say OK. And in the brackets here, which I incorrectly typed into before, I'll put this A, comma, B. OK, what do I do next? I check the next step. I'm one step ahead anyway. And now I'm going to, in my little box here, do a display statement. And what will I display? The square root of A squared plus B squared. Now, John, I know you're going to laugh at me here. When I practiced this before, because my previous display statement I had put in inverted commas, I did display A squared plus B squared. And when I ran the program, I put in A equals 3 and B equals 4, as is ever so predictable by maths teachers. Do you know what it displayed?
It displayed square root of A squared plus B squared, because that's what you told it to display.
It is, my friend. But I won't make that mistake again. Now I'm telling it to display the square root of A squared plus B squared.
Yeah. And that's why sometimes, you know, in a classroom context, if you're leading your students for the first time through this, you may want to sort of see if they could troubleshoot it before they actually do it themselves. You know, say, well, okay, what do you think the difference is when we put these variables at the top? And, you know, what effect do the speech marks have, and if they're in or not in, and some nice discussions rather than actually, you know, let them see it happen, actually thinking about what may happen.
Yeah. And a lot of the learning actually is through the mistakes.
Yeah,
I'm just going to make this a little bit bigger again.
Can you notice as well there, Brian, that when you went to variables then, that the other variable you had before didn't come up? And that's because you've gone into a completely separate problem. You're now 2.1. If you're at 1.3, it would come up as another, both the variables would be there, which is no dramas, but it just, it either simplifies it like yours or obviously clutters it up like mine will be.
Yep. And that's the thing. I worked on this a little earlier. You can see my tab coding, and by the time I got to the end of the skill builder in the application, I was running a program, a misspelled hypotenuse apparently, and it actually it reported back. I'll just quickly show you. Well, you can see the text on that, the code. So it asked for define hypotenuse, hypotenuse 2, which I didn't need the 2 because I misspelled hypotenuse anyway, AB, and display, I've got in inverted commas, leg 1 equals, comma, A. So what happens when it executes, it types out, it displays leg 1 equals, and inserts a space, and then outside of the talking marks, A. So it would type in the value A as the user had put in, and then here the value B, and then display hypotenuse equals, and it put out the calculation.
And notice the comma in between both of them as well.
Yes, oh yes, that's That's the important thing. So there's a comma here. So after the inverted commas for what's literally going to be displayed, I put a comma and then the variable that will be presented.
But again, I think there's some really nice lessons for the students to learn. I quite like it when it doesn't work out for them first time, because obviously they get that immediate feedback from running the program. It may give them the error and tell them where to go to, but it's a really nice it's a really nice try and check that they have to do themselves. And I think I've seen that that sort of persistence follows through into their other classwork, where they then start, okay, I didn't get the right answer for that because the back of the book tells me this. Right, where's my mistake? Rather than perhaps putting their hand up and straight away asking the teacher.
Exactly. Yep. And the learning is through the mistakes, really.
Yeah.
So there's a few illustrations of that. So John, I'm thinking I might hand that ball back to you and show what really happens in your classroom.
Sure, Brian, that'd be lovely. As long as my my internet works, hopefully as efficient as yours was, and better than Rodney's. How's that?
Oh, we're on
my screen?
in Yak and Dander.
I've just one of those big old satellite dishes on top of my house here, you know, like the big old-fashioned ones, so that's what I've got.
I'm seeing your screen well, mate.
Beautiful. Okay, thank you, Brian, and good evening, all. So, yeah, as Brian said, I've been doing programming or coding on the TI calculators for many years, so I think it's great that there is now support on the TI website with the 10 minutes of code that Brian showed. The supporting of teachers to get their students involved in coding and using a device they already have at their disposal is fantastic. So I'd like to show you some of the programming or coding that I use, perhaps in a slightly different approach, where potentially you could just intertwine it into your regular teaching of mathematics. So one of the topics that I've used to introduce that fact that the TI calculator can produce a code is with quadratics, in terms of solving a quadratic equation using the quadratic equation formula. Now, I like introducing it here, as students have done plenty of heavy algebra during this topic. They've rearranged equations and they've used substitution. So I sort of want to give them a bit of a break from this, but at the same time see if they really understand what values they need and the syntax they need for the quadratic equation formula. So as an intro, I would normally, and I've got some pages here, I would normally show them this program. Now, like Brian said, we can split the screen. I will leave it here for you guys to see. I'm using it in document preview because I'm using the teacher software. Obviously, Brian had it in the handheld view, but in either of these, it still works the same. Some of the functionality still works. You can see that I haven't got control over the calculator the same. If we go into the handheld for a minute and do what Brian said, and we go to page layout, ungroup, then there's that page, and now put it back to computer. So there's that page, and here is the next page. So that's the program. So normally I would say to students, hey, look, I've created this program, and I chose this one very much to start with because it gives them enough information that they need to work on the quadratic equation formula without sort of giving too much away, and also they can check their answers. So we'll do what Brian said and go to variables. We're going to work out the AP of a rectangle. Now you can see here that the way that Brian showed it, I think it was with the hypotenuse that you need to put values in to parentheses, is one approach. I'll show you another approach later. Obviously, if you're going to use this approach, you need to know sort of what the syntax is, I suppose, that you need to put values in here. And there you go. So length of the rectangle, yep, is 3. The width of the rectangle was 7. Fair enough, that's the two numbers I used here. And the perimeter of the rectangle is 20. Nice. And the area. So as I said, I'd get my students to think about, well, that's a program I've created. If you don't believe me, then we can, could run it again, or I could go back in and copy it. Let's just run it again with some different numbers. There we go. You can see that at the moment it's not too much of a clever program, because you sort of want students to try and see if they can break the program. So you could say, I quite like a student who goes, I wonder if this would work. As long as the negative I used was right. There you go. Well, that doesn't make sense, and obviously we can't have negative lengths, but you'd think, well, okay, you'd like to think a student could create a program that so you can have negatives as a length, and hopefully nothing too rude that they'd put in their program. So just to show you that program, very simply, and this is what I then would show the students, and as I said to you earlier with Brian, that perhaps get them to suggest what may the program consist of. So we've got display like Brian showed. So up in here, these are obviously the variables that people choose, the values. And then it basically just displays it with the length, displays it with the width, and then displays the perimeter with a little calculation at the end, and the area. And I'd like to point out here that just be mindful that we must have that dot there. If we don't have the dot, which is obviously the time, so we just have WL there, and I go to, obviously like Brian said, check the syntax. Doesn't it? Should have given me an error there. No, it's stored successfully. Okay, let's go back to the calculator screen. There we go. Choose our numbers. There you go. Variable is not defined. No value is assigned to the variable. So when it checked it said it was okay, because there was nothing wrong with the program. But when it tries to run it with some numbers in it, it comes up with this error. And if I go to it, it's then saying, you can see it's on this line. You can see it flashing. Brian, can you see that flash?
Yep.
And
I'm thinking that's what it is. The actual coding lines make sense.
That's right.
So the syntax within the program is good, but it's just the problem was with the variable.
Yeah, and that's the nice thing for the students to pick up on. Obviously, in normal calculator speak, we can get away with that in the normal calculator screen, and it works fine if the values are stored. But here, the computer's thinking that's WL as a variable, not W times L. So hence the reason why we need to put the times in there. Okay, so moving on. So this would be the one that I would hope that the students would create. Something like this. I'm just going to move there's my little cursor, there it is. Just going to move the screen over so you can see it. So again, this is really something that I'd hope the students would create for me. So let's just show you how that works. So this is a very basic one. And what I would then do is I'd either use Navigator to share it around to other students, or perhaps if I was using the iPads, then I could get them to email it to me, and I could show it on the screen or air server it. But it's important that they share it with the other students, and they perhaps talk about it as well, about how they produced it, why it is the way it is, and perhaps other students to critique it. So let's just choose some numbers for the quadratic equation formula. Let's go something fairly safe. I like to think we know the answer to those. And there we go. So we can see how that all fits quite nicely into the formulas. But this formula, again, we talked about hopefully students seeing that they can break it, does get broken. Brian, any suggestions of some numbers that would break this formula or prove that it's not foolproof?
How about we try something like A equals 1, B equals 1, and C equals 6?
Oh, you meanie. Correct, well done. No real calculation. Put you on the spot there, well done. Thank you very much. And you can tell, again, there's a nice bit of learning that goes on here. I think that lots of times the students move away from these messages too quickly because you want them to look at that, understand what it's really telling them, and then actually go to it. And again, here you can see that it's on this line, and nice for the students to work out why is it on this line. So again, we could then evolve from that. So you say, okay, well that's great, but it only starts to work for a certain amount of time. And that's where what Brian was saying earlier about us talking about, that's a simple program, but it starts to fall down. We're now going to look at the decision-making program. So if we go back to that one, here's one that I created earlier for a quadratic equation formula that then makes some choices. And there we can say, and ideas of this come from the 10 minutes of code. So I think the nice thing about the 10 minutes of code is if you've never gone coding before or not used TI-nspire that much, it gives you a solid grounding of what to do, and then I would see that you would use this in your own way in the classroom. And I found that with my students, that I would show them, we would discuss the quadratic equation formula 1, and they would produce it, and then weeks later, months later, when the students are learning another topic, you would see some of the students busily working on their calculators, and not making games up, I might add, Brian, but actually coming up with programs for other things they were doing, whether they were using the sine rule and the cosine rule, or other functionalities. And I think that's really powerful, that they're seeing how they're making choices about their learning, and they're seeing that there's these other tools out there to help them, and that I think is really powerful. So we can see here that what I've used in here is an if and then statement. All those are in this, and you learn this as we go along in the control section here. So there's an if then. I've got another program in a minute that uses the if then else, and here's the looping ones that I will show you, and another similar looping one called while. And they're fairly obvious what to do. Again, the 10 minutes of code leads you through it, so there's no problems. But also, Brian mentioned earlier that if you needed more help in the teacher's lounge, I like that word too, although, yeah, it's not perhaps as exciting as a nice coffee machine and some fresh bagels or something. On the teacher's guide down here, there's a really nice, takes you to a really nice page where it gives you a nice filter, and you can learn, where are we? Here we go, there's loops. It'll give you an example of what to do with loops. So really supports you, and this is just the website that anybody can access for free, really supports you to understand what a loop does, and so all the way through it with examples, as well as the 10 minutes of code as well. So that's there in the Teacher's Lounge.
Now, John, if I could just ask something there, or re-ask a question that's come through in the Q&A.
Yep.
People asking, with the menus and the commands like the display and the request and so forth, and the if and the then, is there a list of all these commands and a concise list of these commands and what they mean? I know in that Teacher's Lounge e-guide, there's I guess, chapter by chapter dealing with these things. But do you know of a concise list of these?
That's a great point. I know that we have a concise list for the TI-84 CE and 84 Plus, which we were using last night. I actually had a brief look earlier today to see if there was a concise one for the nspire. I haven't seen it as yet, but I would perhaps ask the people at TI tomorrow, and if there is, we'll get them to put it on the link it to the webinar. And if there's not, then perhaps we can come up with one, Brian, between us, and we can include it then. But not that I know of.
Yep. I do know in the general guide for TI-nspire, there's pages that list everything that's in all the menus. But of course, we want to know what to do.
Yeah, yeah. That's a great question, and I think that we'll perhaps have that one as a follow-up to participants, whether it be live or on demand later on, I think. So I'll just come back to this one. Thanks for that, Brian, by the way. Please, if you have any more chat questions or anything, please pass them through. Brian is obviously looking at those as we speak and can make them go live. I actually can't see it at the moment, so I don't want to sort of break stride, but please, if you have any questions, put them in that chat window. So if we look here, I've added a few extra things. I haven't put a variable up here because I sort of want it to be more led in the equation, so we've left that blank. I've also put this line in. What this does is it makes only these variables available in this section here. So you don't want either of these variables perhaps to go out of this program, but equally you don't want these variables to be affected from sort of outside in other pages where perhaps A has already been used for something else. So that's why I put local there. Nothing's very different to start with, but now we change it from a display with the comma at the end to a request. And you'll see how that works in a minute. So we then have the formula here. Obviously, this is working out the discriminant. And again, I will show you that we want to store that discriminant equation as another variable. In this way, I've used the store button, which is the arrow. I could also use the, I don't know what the proper name is, Brian, but the colon with the equals after it, which is obviously the get. I can't think what official name it has. But we can use that one as well, and that would be the other way around, and I'll show you that in a minute. So obviously if D is less than, then display this, and end it. If D is equal to this, then do this, and display it. And if D is greater than, then display the 2. I'll just show you that in action. So again, I like what Brian said about just coming up with it here. There we go. We're going to run it. So enter. And here we can see how the request comes up differently, like a nice little icon. And also I have the sentence behind, which I quite like. So the program sort of fits quite nicely now. And again, these are nice activities that you could set your students for homework. And then they can either show you the following day, or they can email it to you, to create a program like this. And obviously you can easily find plagiarism, because if they're exactly the same, you've got to be a bit fishy. In the form, what is A? So now we'll go with Brian's one, which he said earlier. Oops. That's interesting. There we go. I'll use that on my keyboard. B, what did you say, Brian? I think it was 1 again. And C was 6.
I was going to go with 6. We'll sit way above. Yeah.
Sorry, there are no real roots. So there you go. There's that program in action.
Yeah, but right now, I'm sorry, John. I was teaching complex numbers yesterday, and I did exactly that. And I got some answers.
Yep, and I like that as well. Thank you for passing that one back to me. You can see here that I'm just using the CX. Now, obviously, the reason I mentioned that is that it's the non-CAS version. If we had the CAS version, we could get some more cleverness going on, and also I could adapt this formula to show it in a much more clever way. Quite easily, I could sort of manipulate this display to be a blend of the variables, I suppose, or values that it finds, and normal language as a sentence. So I could actually show it in there as well. But yeah, thank you, Brian. Always nice to keep me on my toes. So here's another one that I've done. I've used a very similar format. There's the local display. There's the request as before. Restoring it again. Now, here the form is only slightly different. It's a then else. So you can see that this one's a then else, and this one was just a then if. But both styles work. And again, the 10 minutes of code leads you quite nicely through discussing those. Right, moving on. All right, so this is a loop one that I created, and I got this idea from a question on the Australian Mathematics competition from last year. My son did this one, and a lovely little question. I really like it. I love the visual for this question because I think it fits really nicely into the whole thought of what a loop is. And even though it's a year 3-4 question, producing a program for this for our students, I think is valid at any age. Can you produce me a program that will solve this for me to save me having to do it? So here's the one that I created. Again, just linked it to the question paper. We've localized all those variables just to make it easy. And what I've done here is I've made it a bit cleverer or a bit more open, I suppose, by letting them choose the starting numbers rather than it having to be the specific ones in this question. And and we've used a statement here called a while, which I haven't used before. So while S is less than or equal to G, which S is standing for the starting number, while the starting number is less than the greater than value, display S and then do this calculation. And notice what I do is that it replaces the old S with a new S through a calculation. Now I will just show you how we can change that around. So I'll run this first and then I'll show you how we can change it around. And then end while when that actually finally happens. And this line here at the end is quite important. And I'll show you why it's important when we go through it. So here we go again. Variable. There it is. Press enter. So what is the starting number? Well, if you saw the question, it was starting number was 5. Hey. Now this is interesting. How about this? Brian, do you remember the other day how my mouse stops working all of a sudden? If anybody knows why your mouse all of a sudden will move but won't click, I'd love to know. It's something to do with this laptop. I won't blame my school, but there's something going on. Anyway, I'm back to the touchpad. Here we go. -2 because it's not adding a value, it's taking away a value. But the multiplying was by 3, and it wanted to be greater than 50. So I like these text boxes. I think that they work much nicer on the request rather than actually having it in the define at the top of the page. And there we go. We can see now that the starting number was 5, the adding number, the multiplying number, greater than, and it goes through it. Obviously 5 take away 2 is 3, times by 3 is 9. No, it's not bigger than 50. Put it back into the formula again. Take away 2 is 7. Times by 3 is 21. No, it's still not bigger than 50. And if I didn't have this final line here, then it would stop at 21. But obviously that's because the new value has gone over 50 and therefore it dies. The program, the while program ends, as you can see here, once it goes over 50. But we still want that final value shown, hence the reason why I put this display line in here. Is there anything you'd like to add about that, Brian?
Looks lovely to me. Yep.
Well, thank you very much. You smooth young man, you. Now, another, and probably the last one, and I got the idea from a friend of mine in Canberra about these key aspects of coding. I think the final one is really how you have what's a subroutine. So a subroutine is where you have one program within another. So maybe you don't want to recreate or copy and paste the same programs in. You want to have them as separate ones, but they sort of, you're running one program, it shoots off to another program, then comes back again. So if I just show you an example of that, and that will be me finished. Where's that time gone? Hopefully people are still listening and not too bored.
Having fun.
They are. Well, here we go. We've got to define again. It's a test. We've got an X back in here this time, so I'm going to have to put a value in there. And even this, you know, at the start or, you know, when the students are learning, well, student, what do you think is going to happen when I do this? I choose test 2 and I type in 5. What's going to happen? And you'd like to think that students will say, oh, you know, so you're going to get 25 come back. Beautiful. And notice it shows the 5 and the 25 because the display is the X, which was 5, comma, these speech marks with it, or parentheses with it, sorry, speech marks with a gap in between. It just puts this gap in here, and then obviously returns X squared again. And that's all that program does. Nothing more exciting. And really, this example is not very exciting either, but it shows you how you can then put a subroutine in. So now we've got a new program. This time there isn't an X there. We're going to localize the X, so it only works within this program. And we've now got a for statement, so saying for X, from 1 to 5, replace with X, with 1, sorry, and then it works through. It's a sequence. It goes from 1, 2, 3, 4, 5. But then here, we now put in the other program. Simple as that, just literally either from the var menu or just type it in. And notice it's gone to italics, which means it's already being used somewhere else. And there's the end for, because we've got a for thing going on here. We've got a sort of little circuit going on here that we need to keep enclosed, and then the end program. So if we run that, well, test 1, doesn't ask us to put anything in. And there we go. Runs through all the numbers from 1 to 5. That's what it says here. It then jumps into this program and does each of them squared. And there is our answers. So again, a nice little example. Very simple example, but an example of how you can have one program hidden in the other. Brian, is there anything you'd like to add at that point?
No, I think I really like the idea of program within a program, and you see it happening there.
Yep.
That's it just calls it in. So if we've got time, I would like to show that innovator type idea, or just quickly mention it. Unfortunately, we're not hearing from Rodney again. He's packed up and gone home.
I know.
He's been muted. Our technician Foxy is still sitting on the line.
I'll pass it over to you. So I'll pass that over to you, Brian. It should come your way right now.
Righto, mate. Now, just while I'm organising my screen share, can I ask you, John, to check the Q&A, please, because there was some questions there about some of the coding that I wasn't quite sure of. But it's a question there saying what was happening with the define statement there. So it's in the Q&A, just back a couple. And you're seeing my screen now, but I'm just going to scoot back to that PowerPoint because this was the slide that I wanted to get to and promise to mention if we had time. Coming soon is a thing called TI Innovator. I've only seen it in development, but you can see here a board that connects into either the TI-nspire or the TI-84 series, and we can have little lights and buzzers, and you can see the ports here where you can connect in all your favourite sensors, like your temperature probes and your pH meters and your light meters, voltage meters, whatever your favourites are, and connect that also in turn to a breadboard here. So it's students playing with the electronics and using the code to actually drive a little bit of robotic STEM applications. So the programs are not just talking and sending information out, but they're also listening to the environment and doing something with what they read in. So with the big focus on coding and STEM, I think this is really going to take off big time. Just quickly addressing another question or something that was mentioned, the difference between when we initially put in, I'll just go back to a page here. When we initially put in a new program, we had the option to go program or function. And someone was asking, well, what's actually the difference between the two? Well, the deal is that when we run a program, I'll just jump out of that for now. When we run a program, it deals with the variables and spits out a result, and that's it. Good luck. It was nice. So it could be the hypotenuse of, or hello world, or it could be the hypotenuse for a triangle. And just to prove to you, this is where I had my display statement incorrectly set up, because I had the inverted commas. If we set something up as a function, so here's one here called, I've just called it hypot, and it was in fact the very next lesson or the very next skill builder, the one that I didn't show you before the application, and stored as a function. This time hypot is going to be as a function, and what it outputs, or what it does here, it can be used elsewhere in the calculator. For example, if I go to the next page, and I've got a graphing screen, as you can see, and a funny looking graph, and I've graphed the graph of hypot x3. So hypot is known on this page. So hypotenuse x3, and you can see I've actually put in the 0.45. So this is saying if I have a triangle where one side is 4, then the hypotenuse will be 5. But let's just grab that. If one side was, say, well, let's just run this up to 6. And the hypotenuse is going to, and of course the other side is 3, so I've now got the hypotenuse being 3 root 5. So a triangle of side x, where x is 6, and the other leg being 3, so these are the two legs, the hypotenuse would be 3.5. So this is now showing us how the hypotenuse will change where one leg is fixed at 3 and the other varying.
Yeah, so thank you, Brian. That's a really good point. I'm glad you clarified that, because I think that's a really nice use of actually, and clearly shows the difference between those two ways that you can have it. Yeah. So I'm hoping people got some benefit out of this evening. I'm going to throw the ball back to our Texas Instruments host, Peter Fox,
who's been sitting there online, and Peter will close us out.
I can do that, certainly.
With telling us some of the other goodies that are coming down the track, because he's privy to all sorts of exciting stuff that we aren't necessarily knowing. Isn't that right, Peter?
Yes, I do get some of these little secrets. So I thought I'd just share a quick one. I think I shared it with John earlier on today. There's something called Collat's conjecture, which would be a lovely one for students to program. If you've never seen the problem before, you start with any number. If it's odd, then you multiply by 3 and add 1. If it's even, then you divide by 2. And then you just repeat that until you reach 1. It's a conjecture because that's never been proven. So I kind of like students writing the code literally like that, and then they interpret it digitally or in the coding language. So you'd request a number, and while n is bigger than 1, there's a little command they'd need to learn in there, mod n, comma 2, which really just says remainder. So if my remainder is equal to 1, and I've divided by 2, then I must have had an odd number. So, moving right along, if you want to watch any one of our webinars afterwards, you can either view them on demand, or we also put them up on YouTube, so you can search for them on YouTube. The YouTube handle is down the bottom there, but generally speaking, if you're looking for something Texas Instruments and you're specific about what you're looking for, you'll find it there on YouTube. The other thing we have is some more workshops for schools and teachers coming up. We call them Learn, Energize and Connect. We've got a couple of them coming up for our Queensland teachers. A quick tour of Rockhampton, Townsville, Cairns and Brisbane. Those ones are an afternoon of STEM, which will include a degree of coding in them. And then we've got another one in Canberra, the ACT. That too will have a bit of coding in it. And we've got one happening down in Sandy Bay in Hobart, nice part of the world. Not saying that the other parts aren't, but I've been down to Sandy Bay, it's very nice. And if you're from Victoria, then we've got some happening in Mornington and another one in Mount Waverley, a big one, which normally gets about 150 or so people.
We've also
if you're not already subscribed, what was that, sorry?
Sorry, Peter. Sorry about that. We've also got some happening later next month in South Australia. It's being advertised by MASA as well. So,
beautiful. If I can get the details for them, we can throw them up in our future webinars. That would be good. And of course, if teachers want to know about them, that's a good segue. Thanks, John. They can check out our e-newsletter, and they will keep up to date on all the events, local and national. It's not quite the Channel 9 news, but it certainly gives lots of relevant information. And if you have any questions, if you're in Australia, there's the toll-free number to give us a call. If you're over the Dutch, then you can give us a call on the 0800 number. I don't think I saw any New Zealanders on our webinar tonight. And I don't need to go back to John. We know and have met John. But I think we're just about finished. Let's pay tribute to Rodney. Let's just put him up at the end there. Rodney was our host, but unfortunately, due to technical difficulties in Queensland, he fell off the webinar. Okay, and thank you, everyone. And in particular, thank you for Brian and John coping with the technical difficulties that we had this evening. And we'll call it quits from then. Thanks very much.
Thanks.
Thank you all.
Good night.
Good night.